Team Zeus from University of Sherbrooke in Quebec, Canada presents Steve, this year's submission to the University Rover Challenge. The team is composed of 10 members, 3 of which are studying in electrical engineering and 7 in robotics engineering. The robot is the evolution of Zeus's submission to the Canadian International Rover Challenge, in which it took first place in the 2021 event. The rover is mainly constructed in aluminum and hollow carbon fiber tubing, allowing it to be very sturdy while staying as lightweight as possible. It uses a rocker bogie system to help overcome obstacles while ensuring the wheels are maintaining contact with the ground, even on rough terrain. The wheels are a custom 3D printed design made of TPU. Their honeycomb structure allows an elastic deformation to help gain traction on solid obstacles while absorbing shock and minimizing weight. They can endure a lot of wear and tear with their solid and thick outer shell. In the extreme situation where one would break down, the wheels are easily serviceable with their screws exposed, ready to be swapped out. The rover currently uses a 2.4 GHz dual antenna system. Testing has determined that even without direct line of sight, the rover can still communicate for 1 kilometer. The base station uses a directional antenna, which is rotated towards the rover using its GPS coordinates and the signal strength feedback. Furthermore, the antenna can be easily transported with its own onboard battery, allowing us to control the rover from virtually any environment in a variety of situations. To assist in different missions, the robot is equipped with multiple onboard cameras to localize itself, detect Arugo codes, and give visibility to the operator. A Z stereo camera gives us access to visual odometry, helping to avoid obstacles. In addition to the cameras, the rover uses a dual RTK GPS system during its autonomous tasks. To get its global positioning at the centimeter level, and a 9-axis IMU allows it to get its global orientation in relation to the magnetic north. Those odometry sources are fused together using an extended Kalman filter. A Jetson Xavier NX is used to process the data and then using the A-star algorithm, plan the optimal path to reach the goal. The local path is calculated using a dynamic window approach algorithm to avoid short-range obstacles. The robot is powered using a 16,000 mAh 4-cell lithium polymer battery pack. Through testing, it has been determined that a single battery pack is enough to power the rover for up to 3 hours, even in the cold Canadian weather. A custom-built PCB is used to monitor and balance the battery cells to ensure that performance is always maximized. A lightweight and robust robotic arm was built using carbon fiber hockey sticks generously given to us by the Montreal Canadiens. It has 5 degrees of freedom as well as a 2-finger gripper from Robotic, a local company. A custom case has been printed to remove unnecessary weight from the effector. Linear actuators are used for elbow and shoulder movements, providing enough strength to lift 5-kilogram objects. The arm has a range of 1.32 meters from its base, allowing it to reach both the ground and targets located at a 1.5 meter level. It can pick up objects and rotate itself to store items on the rover's back for easy delivery. The gripper is not only able to pick up a range of differently shaped objects, but also to maintain high torque while doing so. DC motors on a worm gear assembly allow the arm to have 2 degrees of rotation on the wrist. It is dexterous enough to manipulate an Allen key and type on a keyboard. A camera mounted near the gripper allows the operator to locate the end effector's position more accurately, while the other one on the shoulder gives a better idea of the task at hand. The science module will be located at the center of the robot, underneath its electrical box. It uses an Archimedes screw, which can be lowered to the ground for picking up samples. A carousel, powered by a stepper motor, indexes up to 8 different samples while maintaining memory of their position and scientific results. Different kinds of sterile and fertilized dirt are used to test the scientific process as well as the mechanical system. A collection cycle is simple. Loosely packed soil is gathered from the ground by moving a worm screw, and the Archimedes screw brings it up into a funnel that will deposit it into its corresponding vial into a carousel, avoiding cross-contamination. The carousel then rotates to allow our multiple sensors to access the samples and to determine whether there is extinct, extant, or no life within the soil. To find signs of life on rocks, a UV camera will be used to detect for signs of lichen or other living organisms. Thank you for your time and consideration. Team Zeus is very excited to bring Steve to Utah, and we are looking forward to seeing all of you there.